So, hello everybody. Thank you for joining in today's webinar and taking your time to join in. The topic of discussion for today is optimizing your 3-axis finishing operations using SOLIDWORKS CAM 2021. I'll show you a few tips and tricks that I've come across that works actually really well in getting the desired toolpath that you need. So my name is Paul Nishihira, Applications Engineer with GoEngineer, and I'm actually out of the Northern California office. Okay, so here at GoEngineer, ensuring that our customers have access to the latest technologies is our first priority. Certified, instructor-led training empowers our customers with a broad skill set that contributes to the success of their businesses. We also offer comprehensive resources built up from many years of technical experience, and it's available to everybody that's interested. So if you'd like to find out more, feel free to contact us directly, or you can even visit goengineer.com. It's actually a very user-friendly website. Okay, so before we dive into SOLIDWORKS, I'd like to review what the multi-surface feature is and what it does when using SOLIDWORKS CAM. So the multi-surface feature command, this allows you to create features from the model faces and surfaces that can be machined with numerous 3-axis milling operations. These operations include area clearance, which is primarily known as a roughing operation and used to remove the majority of material stock from the part model. Z-level, which is primarily used as a finishing operation of the part model. And of course, we have flat area, which is another finishing type operation which machines the flat areas of a multi-surface feature. So the Z-level operation is used as a surface finish contouring cycle that removes material by making a series of horizontal planar cuts, and it follows the contour of the surface at different Z depths. This actually gives the toolpath some unique characteristics as it starts from the highest location on the model and it works its way down. The Z-level operation is ideal for steep walled areas, but generally not used on parts with flat or near flat part geometry. And actually that's where flat area will come in handy. So speaking of flat area, as the name implies, a flat area operation is used to machine the flat areas of a part. It uses a roughing pattern to remove material on the Z levels of flat faces between the top and bottom of the surface. One thing that's important to know is that this finishing operation only generates toolpaths on completely flat areas. So some things to consider, and this is what we're all here for the webinar. Okay, so when optimizing your finishing operations, there's a few things to keep in mind. Number one is going to be the cutting tool type and diameter. This is going to include flat, bull nose, ball nose end mills, or even special tools such as like a lollipop cutter, which are all available from the tool database, the tool crib, or even from the SOLIDWORKS CAM tools tree. Making changes to the operation parameters dialog. So again, when I jump into SOLIDWORKS, I'll go ahead and talk about some unique things that you can do to get the desired toolpath that you want to have. The use of contain and avoid areas, and this includes sketches and or model edges. And if you're not familiar with contain and avoid areas, it's basically utilizing these SOLIDWORKS pieces of geometry, again, sketches and model edges, to either contain a toolpath to a certain area or to avoid it in a certain area. And then finally, surfaces. So believe it or not, after all these years, having additional, I call them check surfaces, created in your model will actually help you obtain the desired toolpath that you need. Okay, so let's go ahead and take a couple of example look at inside of SolidWorks. So let me change my screen here. All right. So it's going to be assumed that everyone is familiar with the model setup. And when I say model setup, that would be the origin point, assigning the stock material and whatnot. We do have additional video resources here on the GoEngineer YouTube channel, so definitely check them out. But I'll go ahead and just highlight it just to kind of go and make sure that we do have everything set up correctly. So of course, on the SolidWorks side, in the feature manager tree, I have my SolidWorks coordinate system, which I'm actually going to be using as my work coordinate system. And I have a couple of sketches up here as well, and I'll talk about how they're all going to play into part here later. Okay. So over on the SolidWorks CAM feature tree, and I'll go ahead and bring up the SolidWorks CAM command tab. Okay. I went ahead and defined my machining environment, and this is also going to include the setup as well. So let me bring my menu over here. Okay. So it's very important that you do have your fixture coordinate system set up. In addition to that, I have my stock manager set. And then I've also inserted in a mill part setup and created a multi-surface feature. And again, these are things, they're basic fundamentals. And again, you can also find them with other videos here that we offer at the GoEngineer YouTube channel. So with the initial area clearance, which is the roughing operation and the Z-level finish, I'm going to have just default settings. There's nothing special about them. This is what I'm going to have straight out of the box. Now, this webinar is covering the finishing operations, so I went ahead and temporarily suppressed my area clearance. Again, it's just a matter of right mouse clicking on it and then click on either suppress or unsuppress. Okay, so if we take a look at this Z-level finish, you're going to notice, and again, with default settings, that it does a fairly good job as far as using the 10 millimeter diameter ball nose end mill. And then if we go to the Z-level tab, and this actually goes back to that one slide that I was mentioning as far as things to consider. So we're going to make some adjustments to the operation parameters dialog, and this is on the Z-level tab. So again, with the default settings, what we currently have is under depth parameters, the method is currently set to constant, and then the cut amount is 1 millimeters. So what this indicates is that with this option selected, the distance the tool steps down is based upon this specified amount. And again, it's 1 millimeters. And you're going to notice that it's fairly large step over, so you might not get the desired finish that you want. Once upon a time, I used to do tool polishing in addition to CNC programming and machining. And I can tell you it's not a very fun job. It's very labor intensive. So I am by all means of the discipline. If you can have the machine do all the work, then it's going to be less work on the back end, for the manual process. Okay, so you can also make adjustments if you'd like, maybe make it a little bit tighter and see what kind of a finish that you get. But ultimately, though, we're still going to have some fairly large step overs. Okay, so what you can do in lieu of that, so let me cancel out of this. I'm going to go ahead and make a copy and make some adjustments of this current Z-level finish operation. Okay, so all I'm going to do is just hold down the control key, left click, hold and drag, and then make a copy. Then I'll just do a little bit of reordering right here. And then the first thing I'm going to do is make use of a containment area. Now, with this particular model and the way it's set up, the majority of the features are actually going to be this inside cavity. But to prevent any excessive tool movement, maybe outside in the of the cavity area, I'm just going to go ahead and put a nice containment area in there. Now, true, you could pick the model edges and then have it join all the way around to contain this toolpath. But what I did over on the SOLIDWORKS end was actually create a sketch using the convert entities. Okay, and then I just did it all in your loops. So this is actually going to be helpful over here when we get into the CAM side of things. Okay, so let me jump back over here. Okay, so adding a containment area, it's very easy to do. You just highlight the operation that you want to affect, right mouse click, and then add in a new contain area. Now you notice that when you have your valid sketches available to you, I'm just going to pick this sketch number 2. Okay, and you're going to physically see it highlight here, and it's basically telling SOLIDWORKS CAM to stay within that area. The other nice thing down over here towards the bottom where it says offset, you can actually control where the center of the tool is going to be. So you can go tool up to the curve, tool on the curve, or even past the curve. Okay, it's just a matter of selecting these options. There's some additional offsets that you can put on here. So if I were to put in, as an example, something extreme, like 10 millimeters, and then I hit tab, you can actually see the display area update. Okay, that's the 10 millimeter offset. Okay. All right, so let me go ahead and change it back down to 0 here. All right, so again, a lot of flexibility, and this is part of optimizing your finish for the finishing toolpath. So we hit the green check mark and then have that incorporated in our copied Z-level finish. And then now I'm going to go into the actual operation here. So we'll just do an edit definition, and I'm going to jump over to the Z-level tab of the operation parameters dialog. Okay. Now, since I'm looking for a better finish, what I'm actually going to do is change it from constant step over to scallop. For those of you who are not familiar with the term scallop, what it does, it refers to the material left on the theoretical surface between two successive tool passes. So you're going to get that between each step over, there's going to be like a little quote unquote scallop mark. Okay, so a higher value is going to result in a poorer surface finish, and of course, lesser number of passes. Okay, now the smaller the value, it's going to equal more number of passes, which is actually going to yield a better finish. So the cut amount is going to be calculated based upon the scallop step specified. Okay, so I'm going to leave it at 0.01. And then the minimum cut amount, I want to go a little bit tighter. You know, I'm going to maybe go like 0.2. All right. The other thing I'm going to do also is make sure I have hit flats turned on. Okay, so what this indicates is that, and again, this is still in Z-level finish, it's going to take that toolpath, and wherever it sees a flat area, it's going to quote unquote hit that area and then run its toolpath. So with all of my training classes that I teach, any changes that you make, no matter how big or small, I always like to hit the preview button just to see what we got here. Because sometimes you might put in a value, or you might enter in a specific option where it may not generate any type of operation plan. So you can see just by making those small changes, you're actually going to see a much tighter toolpath. Okay, and it's going to take away all of the excessive amount of materials, minimizes the extreme step over, and of course any kind of rework that's needed, you know, once the tool is off the machine. All right, so we'll hit OK, and then we'll make it official here. So another thing that we can do, and let me go ahead and toggle off of my mill parts setup, is the use of a contain area more in like a specific application, as well as adjusting the depth of Z-cuts, the from and the to. So what I mean by that is, if you notice that over on the model, I have that little red surface right there. So I'm going to call this the wall of shame as far as the machining terminology goes. So I'm sure it's probably happened to a lot of people where, whether it's a programming error or maybe another tool got dropped into the cavity of this tool. Just things in life happen, and there's damage to the tool. Maybe we can get away with putting in some welding, and then we need to remachine it. Okay, so what we can do is this. Okay, so I've got my area where I want to concentrate on machining. And then again, just to make things easy on myself, I'm actually going to go ahead and take this operation here, which is the one that I had just dialed in. Okay, make a copy of it. So then let me go ahead and do a little bit of managing here. And then I'm going to just readjust my contain area. Okay, so it's just a matter of right-clicking on it, go to Edit Definition. And then I have this oops repair sketch here. I'll just go ahead and click on that and then take the other one out. And then again, I'll leave it for right now, just to initially see what we have. I'll leave it tool on the curve. Okay, so we'll hit the green check mark. And then we're also going to make some other adjustments here inside of this actual operation parameters. So go ahead and access the Z level tab. I am still going to keep the same depth parameters because I'm very happy with the scallop method and the finish that it leaves. One thing I will change though is change my direction control to zigzag, okay? Rather than having it go in one direction or another, I want to have it be able to kind of go back and forth. The other thing that we're going to do is change the limits here, okay? So right now it's reading it from the top of the material stock. I'm actually going to go ahead and click on user defined, and you're going to see this little pickup point icon right here, okay? So I'm going to click on that, and what happens is that over on my other screen, and I'll go ahead and drag this over, I have this dialog that pops up, okay? And this is going to allow me to pick a quote-unquote point, okay? So I'll just go ahead and pick that right there. And then the X, Y, Z positions are going to be recorded here in the dialog. Okay, so that's where I want to start from. Basically, I just want to minimize any excessive tool movement. Just focus in on the repair area. Same thing can be done for the last cut at. Again, click on user define, and then pick a point. And then I'll go ahead and pick like right about here. Now, the other cool thing about this is that if you want to go in a little bit deeper from that last vertex point, we can just go ahead and say, well, you know, I want to go an additional -1 millimeter. Okay, and then we'll hit OK. And then let's go ahead and see what we got. We'll just hit preview. All right, there it is. So again, just with some minor changes and then making use of some SOLIDWORKS geometry, which is that sketch or the oops sketch, you can see that I'm going to go ahead and focus my Z-level finish just in this area right here. Again, this is a perfect example if you need to do any type of remachining, maybe for some tool repair. It's a perfect application. Okay. Now, in regards to creating a flat area operation, one of the nice things about SOLIDWORKS CAM is that we have already created this multi-surface feature over on the CAM feature tree. Okay, so we're actually going to just reuse it. So here again, I'm going to jump over to the operation tree, and then I'll just right-click, insert a 3-axis mill operation, and we're going to pick on flat area. Okay, you're going to have this dialog pop up here where it's going to ask you a couple of things. Okay, what type of tool that you want, and I'm just going to use the 6 millimeter flat area because I want to hit all of the flat areas on the in the cavity. But you do have the flexibility to add a new tool if you like. We're going to go to the features, make sure that it is referencing the correct multi-surface feature that we had just created. And then the operation itself. What I'm going to use is the default settings from the technology database. That's what TechDB stands for. and then have the ability to edit the operation on creation. So what that means is that if I hit the green check mark, the operation parameters dialog is going to pop up, and then now I can make my adjustments here. Right. So again, it's always a good idea just to check the tool type and the tool diameter of what you got. Okay, make sure that it is either big or small enough to fit in the areas that need to be machined. And for right now, I just want to see what we got initially. Okay, so I'll hit preview. So let the process manager work, let it generate its toolpath, and you're going to notice that because that top face is flat, now I have toolpath on the outside. And this is where the sketches will come in handy for my containment. Okay, so again, we'll just go ahead and accept what we have here. Navigate over to the flat area. And then also, I'm going to make a copy of that contain area and then just drag it over to the flat area. Again, we're just trying to save time here. So I'm just going to hold down the control key, left click, hold and drag and drop it on the flat area. Now I have my contain area applied, and then it's just a matter of regenerating my toolpath and then letting it update with the contain area applied. All right, and then there it is. And of course, if you want to, you can adjust the Z level as far as your depth of cut. Maybe you want to omit this top portion right here. It's definitely easy. It's the same process of what we had done over here in the previous Z level operation. So one other thing I'd like to talk about, let's see, let me highlight this one Z level operation. And I'll go ahead and step through right here. So you might run into a situation where you don't want to have the initial movements of your finishing tool come in right where the edge of the model meets. Okay, there's some applications where, especially with mold tools, you want a nice sharp edge, or maybe it's creating a shutoff area. Okay, so there's actually a way around this. Okay, it's one of the tricks that I've come across in the past few years as a machinist. So why don't I go ahead and save this? And then I'll just minimize this and bring up my other model here. So it's the same part. The only thing different is that I created a ruled surface right here. So basically, I'm just telling SOLIDWORKS to extend it up a little bit. And again, the nice thing about this is that you would just create a 2D sketch. And then if for those of you familiar with the surface geometry, it's just a matter of turning on your surfaces and then creating a ruled surface from that sketch. Now, the great thing about this is that when you do go over and make changes to the multi-surface features, so if I were to do an edit definition, I basically picked all the surfaces because I do want to include that ruled surface there. The other thing that you'll need to do is make adjustments to the stock manager, okay, because you want to physically tell SOLIDWORKS CAM to say, hey, I'd like to start actually from this area right here and then work my way down. So for sake of brevity, and I did create a Z level. And then let me go ahead and see if I can rotate it around so everyone can see here. There we go. So like right about there. Okay, so you can see that it starts well above the actual part, and then it'll take its successive passes. Again, this is all Z level, and then it'll go ahead and machine down the tapered wall. Okay, so this will ensure us that we get a nice, clean, sharp edge as we're machining down. We won't have a rolled lip or any kind of deformation at the actual corner. Okay. Now, true, you are able to hand work it with a file and maybe some sandpaper or some polishing stones, but here again, the whole purpose of this is to save time and money, minimize any kind of hand rework. So, GoEngineer has decades of experience helping companies succeed using cutting-edge, industry-leading manufacturing tools. We are the experts in this industry and in technology and are passionate to help you leverage the power of these products. Okay. Again, if you would like to find out more, feel free to contact us here at GoEngineer or even myself directly. I'll be more than happy to answer any questions. This is Paul with GoEngineer, and I wish everybody a great day. All right. Take care.